Okay, so this is the first time I've ever done this, so hopefully it goes well. If there's any hiccups or flat tires along the way, then we will just work through it, because that's what we've been practicing in the classroom as well. So, for those of you that are watching, I'd like to welcome you to the first, and hopefully not the only, video tutorial on problem solving. That's the topic we're doing today. And basically, I'm going to be doing a few things. One, I'm going to be showing you sort of the process we go through as a class to ensure that we are tackling a word problem, showing perseverance, and ultimately solving the problem using different strategies. So if you haven't seen it already, this right here is the problem-solving map that I created. And the purpose of it is to help students and guide them through steps to take in order to have a complete solved word problem. Over to my right here, you can see a problem-solving checklist bookmark that I have created for them as well. And this is just sort of a check-in to make sure that, again, they've followed those steps in case anything is invisible to them on the problem-solving mat, which sometimes too much stuff can blend into what's important, and so this is just an extra guide for them. And then finally, to my further right, here is our feedback for next time. So this is kind of useful for them when they have completed the word problem to use with their BFF or best feedback friend, or myself will select where they can improve on for their next time. And then you can see here's our qualifiers. So we've got not yet, which means they haven't really been able to show a clear problem solved or strategy. Almost there means that there's aspects of their problem that they've shown some understanding, but there's still work to be done. Got it means that they have, at the standard, completed the word problem. It may be missing some parts or maybe one small key part, but for the most part they've showed understanding and they've completed the problem. Wow is when they are able to go above and beyond and prove maybe in more than one way or show more than one manipulative in how they solved. And that's also including making sure that all parts of the problem have been solved and there is proof on their problem-solving mat. So now that's kind of been explained, we're going to get into basically looking at a word problem and what we can do to sort of tackle the word problem. So I'm going to play around with some of the features here that I have. Again, forgive me if there's any mistakes, but I am not a robot. I'm human, so we will work through them. So the first thing I do is I always encourage my students, regardless of whether they can read the problem once and find the answer right away, to read it a couple of times. This will help with understanding and comprehension to answer some of the questions like, I understand what the problem is about. I understand what the problem is asking me to do. So we're going to do that first. So I'm going to model that. So Mr. Wilson has collected a bunch of cards over the last few months. He had collected 25 rare cards in total. He traded 7 of these cards to his friend. How many cards does he have now? So typically what I do is I encourage, after they've read it once, to put a little tick or a tally on the read box. That lets me know that they have definitely read it once. And I will ask them to read it again. Now, they don't have to read it repetitively over and over and over again, but what I'm looking for is for them to read it throughout their process of following step by step. So we'll read it one more time for good luck, and then we'll move on to our next step, which is, according to our problem-solving checklist, we're going to use cubes. So we'll read it one more time. Mr. Wilson had collected a bunch of cards over the last few months. He had collected 25 rare cards in total. He traded 7 of these cards to his friend. How many cards does he have now? Awesome. So I'm going to give myself another tick. And this is proof to my teacher or my feedback friend that I have definitely read it at least 2 times. I always encourage at least 3 or 4 times in the whole process. So now that we've read, we're going to move on to cubes. Now, CUBES is an acronym that helps us break down a problem. So for those of you that aren't familiar, we'll look at our bookmark here because there's some more visuals to help us. So C stands for circling the numbers. U stands for underlining that question, and we're looking for that sentence with the question mark. That will be the sentence that's underlined. That's what we're really trying to find and trying to answer. B stands for the box, the key math words. Those action verbs that are helping us to understand what operation we're going to need. This one is really, really key. Now E. E can be a little messy sometimes depending on where the student is at. It can represent eliminate, so eliminating information in the word problem that isn't really that important. That's kind of there to essentially mess with the child's math mind and kind of confuse them a little bit. And there's just some stuff in there that maybe we just don't need. So if your child is ready and can discern the difference between information that's important and information that's not, then they're ready for this step, which is eliminating. The other way to see E is evaluate. So this is a good time to evaluate your plan. What kind of operation are you going to choose? What manipulative are you going to choose? And what words help you know and understand what that is. So there's two ways to go about it. Evaluation is always going to happen regardless, even if they do eliminating, but sometimes some students don't need to eliminate and they already can identify what the most important stuff is. And then finally, the S stands for solve, and then the check mark means to check your work. So we're going to go through that part now, and I'll model how that's done in our classroom. I'm going to change the color to blue. So here I am reading it again, and I'm going to look for the numbers, circling the numbers. So Mr. Wilson had collected a bunch of cards over the last few months. No numbers there. He had collected 25. There's my first number. So I'm going to circle the 25. Boom. 25 rare cards in total. He traded 7. There's my next number. So I'm going to circle my 7. Boom. So he traded 7 of these cards to his friend. How many cards does he have now? So I've definitely read it one more time, so I'll put another tick there. That shows that I'm really trying to understand that problem. And our C part is done. Now we need to underline the question. So I'm going to change my color again because we're having fun. I'm going to make it red because it's super duper important. So I always look for the sentence that has that question mark, and I can see the question mark here. And so I'm going to take my cursor here and I'm going to underline the question. This is super important. This is what we're trying to figure out. How many cards does he have now? So our underline the question is finished. Now, B, box the keywords. I'm going to change my color once again to a nice green. And these words, sometimes they stick out and sometimes they're a little hidden. And we have to really use our logic and reasoning to figure out what do these words really mean and are they math verbs? So we have to scan through. So Mr. Wilson has collected a bunch of cards. Now collected isn't a common word for our math, but we know that when we're collecting something we're getting more of. But is that helping us solve the problem? Is that what's the problem? So I'm going to read on. I'm going to hold on to that one. So collected a bunch of cards over the last few months. Okay, so Mr. Wilson just talking about that he's collected some cards. He had collected 25 rare cards in total. Okay, so we know that's how much he has. He's traded 7 of these cards. So something's happening here to his cards. He's trading them. Now this is when we can get into that math talk. Well, I've traded stuff before, and usually when I trade something, my pile might get smaller. And the word problem doesn't say me getting anything in return, so it just means that I've given 7 of my cards to a friend. So traded is going to be definitely a math word. We know that how many is a math word, and it's asking us to figure out a total of something. So how many is going to be boxed? How many cards does he have now? Now I don't see any other math words. If your child thinks that collected is important, they can box it, but they'll find in the end that it doesn't really affect their operation, hopefully. All right, so now that I've boxed my keywords, it's time to eliminate. So I'm going to show with a black color how we can eliminate and figure out what's important and what's not. And you'll notice that when I've eliminated everything, when I read it again for a final time, the most important stuff that's not eliminated, it really makes the whole problem simplified. And then we can work with it easier. So here we go. Mr. Wilson has collected a bunch of cards over the last few months. Now, as important as I am to this problem, it doesn't matter if it's me. It could be anybody. It could be Joe. It could be Sally. As well as collected, I know that I already have 25 cards, so the fact that I've collected over the last few months doesn't really matter. I could be trading cards over the last few months. I could be doing it over the year. That information is just there to kind of mess with you a little bit. So we're going to take it out. He had collected 25 cards in total. I'm going to take out he had and just leave collected 25. Doesn't matter if they're rare. No. So we're going to take out rare in, and I'm going to keep the word cards and total just to keep the flow a little bit. I'm going to take out he. We do not touch anything that's boxed or circled. And it doesn't really matter that he's giving it to a friend. He could be giving it to a dog, cat, unicorn, troll. It doesn't matter. And then we never eliminate anything from our question. It is sacred. We leave it alone. It's underlined, boxed for a math word. That's it. We don't touch it. So now, finally, I'm going to read it for the last time. And I'm only going to read what's not got a line through it. And watch how we simplify the problem. So listen. Collected 25 cards total. Traded 7. How many cards does he have now? And when kids read this back, now that we've eliminated all that jargon, they're going to say, oh, he has 25 and he's giving 7. I know that when you give something, you get less. Your total amount gets smaller. So I know that I'm going to be doing some subtracting. So I'm going to add another tick for reading. We have completed our cubes, and we're now about to solve. So the first thing that I have students do is identify what manipulative are you going to use. This is really huge, and this is what I'm looking for. And you can see in my feedback, it says use a different manipulative to prove. Super duper important. Sometimes we can just look at a problem and be able to answer it in our heads, and that's okay, but we need proof, especially when someone's evaluating it. How do we know that we know? So there's a couple things I could do. I could use Cuisinart rods, 10 frames, counters, a number line, base 10 blocks, linking cubes, and those are really just the main ones. There's other ones too, like a hundreds chart, or I'm trying to think of something else. Linking cubes, well, we already got linking cubes, but yeah, there's a couple of different ones that can be used, but we want to make sure that they're the most effective to help us with number sense. So in this one, I'm going to use a number line. That's going to be my first one. And I'll probably use some counters just to prove. So on my number line, I'm going to change my color so we can see it clearly. Let's do a nice red. Here we go. So here's my number line. Now number lines sometimes can be a little tricky for students because we're used to seeing number lines completed. We're not used to making them and figuring out where the numbers go. So maybe your child isn't ready for a number line yet. Maybe they need one that's already created for them, and that's okay. There's lots of those in the classroom, and ask your parent to create a number line. As we know that the total is 25, so it should go up to about 25 or 30. So let's start making that here. So we know we have 25. Here's my 25 cards. And we're trading 7. So we're going to be going back 7 jumps. And while we go back 7 jumps, we can count backwards. So here we go. 1, 2, 3, 4, 5, 6, 7. So now I know I've got 7 jumps back. Now I can start counting backwards. So let's do it. So 25, 24, 23, 22, 21, 20, 19, 18. I've landed on the number 18. So I'm going to draw 18 right here. That's where we left off on our number line. So If this strategy was effective, we could say that Mr. Wilson has 18 cards left. But you know what? I want to prove, I want to make sure I know for sure that it is the number 18. So I could draw 25 counters. So this is a really good initial strategy for those that are maybe struggling with math a little bit, having that actual hands-on counters. And you can notice right here, just drawing it takes a little bit of time, but on a computer. But in real life, we know that it would be much faster. So I'm not going to make it look any prettier here, but I'm just going to try and draw 25. So here we go. There's 10 counters. I'm going to do them in rows of 10. There's another. And I'm sure there's probably a more fast, effective way of doing this, but bear with me. All in the process of math, my friends. All right, that should be 20. And we need to do 5 more. So I'm going to do 1, 2, 3, 4, and 5. All right, we got there, my friends. Here we go. So let's double check. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There you go. Mr. Wilson miscounted. 22, 23, 24, and there's 25. Okay. Now I've got it. So now we need to figure out, how can I show I've got 25 counters? How can I show 7 being traded away? So a good way of doing this is we can X them out. So let's go 1, 2, 3, 4, 5, 6, 7. So those are the 7 cards that were traded. Now if we count on and see what ones were not traded, we should hopefully be left with 18. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We got the same number. So now we've definitely got proof that 25 minus 7 is 18. And now we're going to show the number sentence just to show extra proof. 25 take away 7 equals 18. Boom. Amazing. So we've drawn our manipulative, check. We've solved. We've given ourselves a number sentence, but we also have this section here. And this happens to be the one part that a lot of students miss. And although it's been modeled, it happens sometimes. So again, we have to make sure that we've written our number sentence, look at our bookmark, and prove our understanding. So we can write a little sentence to answer the big question, which was, how many cards does he have now? Well, we know Mr. Wilson has 18 cards now. We're going to stick that right into our write about it. Now again, we're just looking for a simple sentence to show that they understand what the question's asking and embedding their answer into that sentence. As we move along, we're going to look for that kind of because statement. So, well, how do you know 18 cards? Well, I know 18 cards because I used a number line and counted backwards 7, and I landed on 18. And that's just, again, justifying their communication of their strategy and their process. But we're not there yet. We're getting there. If you notice that your child is and they're able to explain it to you, then that's fantastic. That's really a really good sign. And it's definitely something they look for in grade 3. So finally, it says, check if answer is reasonable. Well, we know the number didn't get bigger, so it's definitely the right operation. We know that traded means to give away. So subtraction has to be a reasonable operation. Is our number reasonable? Well, I could actually double check. So some students may be ready for this, some students might not be there yet. But I will show you an extra way that we can check for reasonableness. I know that if Mr. Wilson had his 18 cards now, and he took back his 7 cards for the friend that he traded to, he should be back to his final total. Okay? So we can do 18 plus 7. So we might take 2 from the 7 and add it to the 18 to make 20. And then because we took 2 from our 7, that makes it a 5. So then we add that extra 5. And that should equal 25. So boom, we've just proven reasonableness, that subtraction, take away 7 is 18, and we proved it by doing the reverse, or the commutative property, also called fact families. So that is considered a complete problem. We've shown proof, evidence, we've used manipulatives. So all these little things here, we can see I read the question more than once with proof. I can talk about the problem is asking in my own words, so that would be a conference with the teacher. I can choose an operation and strategy that finds the right answer and show proof. We've definitely done that. And finally, I can use and show a manipulative that helps me with my strategy. Well, we used 2, so we definitely did that. And there you go. That is how to tackle a math problem scenario using our problem-solving mat and our checklist for problem solving. That, I believe, is the end. I hope this was helpful, hopefully not too confusing. If it was and you have questions that pop up about parts of our problem or what I did or what I showed, please feel free to ask. Again, this is the first time me ever doing this, so I'm sure the more I do it, the better it will be, the more effective it'll be. But yeah, I hope you guys enjoyed, and please stay tuned for further help. Take care, guys.